Welcome back, guys. New day, new topic. So, our today's topic is searching. Of course, everyone knows what searching is. Basically, searching for an element in an array. We have two types of searching: linear search and binary search. First, we will see what linear search is. In linear search, we are searching element one by one from one end to other end. For example, here we have array 5, 9, 3, 2, 7, 16, 15. Now, if we have to find 2, what we'll do? First, we'll go to first element 5. Is it equal? No. Then we'll go to next element. Is it equal? No. Then we'll go to third element. Is it equal? No. Then we'll go to fourth element. Fourth element is equal. So we return 3. That is the index of its position. This is linear search. Now we'll implement linear search in code editor. So I have created a file named search include string. I hope you have got the hang of the basic code till now. Mm. Now you know how do we declare array. So we'll just declare one array named arr of size, let's say 10, and we'll take the input. No, first I will show you directly. Let's say 7, comma 56, comma 100, comma 225, comma 36, comma 24, comma 9, comma 18, comma 24, comma 29, 76. Sorry, we can store only 10 elements. Now, what I'll do, I have to search for element, let's say 36. Now, what I'll do, I'll create a function of linear search. The function data type will be integer because we are returning an index, and index is an integer. So, int linear search, and the parameters we're gonna require are an array, its size, and target. So what we'll do, we'll just run a loop from one end to another. Less than size. So we are just running a loop from one end to another, and we'll see if the element at each index matches the target. So if element of that particular index matches target, if it matches the target, just return the index. And at the end of the loop, if it does not match any element, which means the target is not present in the array, so we return -1. Now I have written the function. I'll just try to search one number. That's a linear search. We will give array, its size 10, and let's say we want to search for 9. So if we have to search for 9 and it is returning an integer, so we will just store that integer in variable x and print that x. Here you can see where target is 9 and 9 is at index 6, so the function should return 6. I'll just run the code. Yeah, here you can see it has written 6. And let's say we will try another element. We say 100. For 100 it should be 2. Here we got 2. Let's say we have another 24. If we search for 24, we should get 8, and we got 8. Now, what if the target does not exist in the array? Let's say 78. 78 does not exist in the array. So it should return -1. Here you go. You can see -1. Now, this is how linear search works. And you can see if the target is present at the very first index, then the time complexity becomes O of 1. And if the target is at the last index, so it becomes big O of n. So best time complexity for linear search is O of 1, and worst time complexity, that is big O of n. Now coming to binary search, note it guys that for binary search the array must be sorted, that is a compulsion. Now we have here a sorted array 10, 20, 30, 40, 50, 60. I'll just show you here without indexing, like on the direct numbers. So what we'll do, we'll take this as left, take this as right, and we'll find the midpoint. So here what midpoint will come? 10 plus 60 minus 10, 50 by 225, that is 35. So we get a midpoint 35. Now what we'll do, we have to find 30, and array is sorted. So we know that 30 is less than 35. So there is no chance that 30 can end up anywhere to the right side of 35. So we just discard the complete array which is to the right side of 35. That is, we discard this complete part of the array and we search now on this side. So right will come here. Now if right comes here, we can see that it will become 10 plus 30 minus 10, that is 20 by 2 is 10. 10 plus 10, 20. So we get mid 20. Now we know that 30 is greater than 20. So we know that to the this side of array we are not getting anywhere 30. So we are only left with one single element 30, and this is how we get the answer. So I'll just show you in the code once. Now let's just sort our array first. Let's say we are storing 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Now we have to, let's say, search for 80, and now we have binary search. First we'll change the function. So yeah, now we'll write the function for binary search. The parameters will be same for binary search as well. Now what we'll do, we'll first define the indexes. We'll define left for leftmost index, that is 0, and right for rightmost index, that is size -1. Now what we'll do, we'll run the loop till our left is less than equal to right, because if it becomes greater than, then the complete situation will be invalid. Now what, what we'll do, we'll find the mid, and mid is equals to left plus right minus left divided by. Now we have found out the mid. What we'll do, we'll just check if the middle index element is equal to the target. Here of mid is equals to target. If it is equal to target, that means we have already found the element. So we'll just return the index, that is mid. But what if we haven't found the index? So there can be two conditions. So first condition, that will be target is less than the index at the mid position. So target is less than element at mid position, which means right side array of the mid is completely discarded. So we have to shift the right pointer. So what we'll do, we will shift the left right pointer to the left of mid, that is mid -1. And another condition will be that target is greater than element at mid position. So in this case we will discard the left side array, and we will shift the left pointer to the right of mid. that is left is equals to mid plus 1. Now this loop will continue till we find the element, and if we haven't found the element until the end of the loop, so we'll just return -1. Now we'll update the function. Yeah, and we are searching for, let's say, 18. We have updated the function and the parameters. I'll just create the terminal. Yeah, now if we run the code, we should get, for 80 we should get 7 as the output. So control shift. Yeah, you get 7. Now let's say we are trying to find 100. For 100 we should get 9. Here you go, 9. Let's say we have to search for 10. We get 0. Now what if we search for an element that is out of the range? Let's say 84. 84 is not in our array. So we'll just guess -1. So yeah, this is how binary search works. And the time complexity for binary search, I'll just write it here. Time complexity for binary search is big of log. So yeah, that is it for this for today, guys. Next we will see sorting in the next video. Thank you.